No, focus.
What's the ruler?
That I was talking to someone, JV girl.
Wow. Alright.
Part of a game mess. You are.
Okay, warm up. Take a look at number 1. Okay, it says, find the area bounded above by the graph of f of x equals 1 over 3x plus 1. And below, by the horizontal line, g of x equals negative 4. Okay, let's graph it, shall we? Okay, what does 1 over x look like?
Can you move the paper down, please?
Yes, I can. Okay, 1 over x looks like this. Okay, you have 1 here, and then you have 1 here. Do you remember that as a parent graph?
The limit.
Okay, so 1 over 3x plus 1 is basically that same graph. It's just like a little bit flatter, but it doesn't really matter. Okay, so sketch your graph over here.
So basically, you only have to sketch the parent function of it.
You only have to sketch like the general shape. Doesn't have to be perfect. Also keep in mind a lot of times on the AP test they're going to give you the graph. You're just kind of like looking at it and then graphing it from there. Okay, now what would the second function g of x equals negative 4 look like? Horizontal line. So negative 4 is here. Okay, now where these do not cross twice, but they tell me the interval that they want me to shade on. So we'll say 1 is here, we'll say 4 is here. Okay, so the entire time, the 1 over x is on the top, the negative 4 is on the bottom. So, do we remember from yesterday how you set up your integral? 1 minus top minus bottom, perfect. So right here, the integral is set up. Okay, top minus bottom. Okay, so area equals the integral of 1 over 3x plus 1 minus negative 4 dx. Okay, focus. Okay, then what are our endpoints? Okay, 1 to 4. And then remember that you have 2 options. You can integrate it all together or you can split it up into 2 pieces. Which one would we do here? Separate, because why? Okay, very good. This one needs U sub, this one needs no U sub. Okay? So that means that I'm going to separate that into 1 to 4 of 1 over 3x plus 1. And then if it's minus a negative, that's really plus the integral 1 to 4 of 4 dx. Okay? Let's do the u sub 1 first. What's my u going to be?
3x.
Okay, u is going to be 3x plus 1. What does that make du? 3 dx. Which means that dx is going to be du over 3. So then I can rewrite my integral. It's going to be 1 over u du, and then instead of putting the over 3 there, I'm just going to put it as a third in the front. Then what's the antiderivative of 1 over u? 1/3 ln u. And then my endpoints are going to change. Remember, originally I had a 1 and a 4, but I'm plugging those into 3x plus 1. So what is, yeah. So 4 times 3 is going to be 12, plus 1 is 13. And then on the bottom, I'm plugging in a 1. 3 times 1 is 3, plus 1 is 4. So I'll get a half ln 13, and then a half ln 4. Then what am I doing with those two?
1/3. You mean a third?
Oh, I did mean a third, thank you. And then what do I do with those two values? F of b minus f of a, so it'd be a third ln 13 minus a third ln 4. Yes, which I'll do in a second. Okay, now remember, that is only this part of the integral. I still have to come back and do this part and then add the answers together. But 4 will be super easy. What's the antiderivative of 4? 4x. What am I plugging in on top?
4.
And on bottom, I'm keeping it a 1. So remember, when you plug in endpoints on regular U-sub, you're not, or on non-U-sub, you're just keeping them the same. 4 times 4 is 16. 4 times 1 is 4. What's 16 minus 4? 12. And then I would do answer 1 plus answer 2. Okay, now, I don't know if you heard what Alex said, but remember that you can also take the third of these two out and then use property of logs to simplify that. So the alternate answer for that would be a third ln 13 over 4 plus 12. Okay, and remember, I would not worry about that unless it was multiple choice and you couldn't figure out which answer was the same as yours. If it was free response, I would leave it like that though and be done. Make sense? Okay, so let's fill in the little top part up here. So your equations should be in the form y equals. And then they should have like a bunch of x stuff. Okay, so 3x plus 1, 1 over 3x plus 1, e to the x. It should be x stuff. Okay, then your functions should pass the vertical line test because that's the definition of a function. And then your last thing is that your integration boundaries are across a domain. Basically, that just means that they're x values. Okay? So if you want to go back and fill those in, huh?
Is it gonna get more complicated?
Not really.
Oh, yeah. Maybe this
Okay.
is something I'll want.
Ooh. Okay?
I don't
So-
want to do that though, and then I bomb the test.
No. Okay, ready to do number 2? Okay. Okay, let's come down to the next one. Okay, now what do you notice from the first equation to the second equation? Okay, these are equations in terms of x. The next one, the equations have what as their letter? Y. So let's sketch a graph. Okay, now remember that if it's the number on the outside, that shifts you up the x-axis. But if it's the number on the inside, that's going to shift you up the y-axis. Remember, it's graphing for x, it's just everything's reversed. So if it's on the inside, I'm going to go up 2, and then which way will it open, to the left or to the right? To the right.
Is it because y is inside the parentheses instead of x being inside the
Exactly. That's exactly right. Okay? Then for my other point, I have y plus 10. So that's going to be shifted up 10 here. And then my graph is going to connect something like this. Okay, because remember, it's a straight line. So this is x equals y plus 10. And this is x equals y minus 2 squared. Okay, now I want to find the area that's trapped between those. So that would be this right here. Okay, then that means the first step that I need to do is find where those cross. So how do you find? Set them equal to each other. Very good. So I'm going to put here intersection. Okay, I think there is one like this on the homework. Okay, so pay attention to the strategy on this. So I have y minus 2 squared equals y plus 10. Okay, I cannot solve that in this form. This is why. If I try to get rid of this squared, what do I end up with on the y on the other side? A square root. And then to get rid of that square root, I'm going to have to square, and it just is an endless cycle.
Do you expand it?
You expand it. Very good. So if I have y minus 2 squared, that's really y minus 2 times y minus 2 again. And I'm just going to expand that side out. So y times y is y squared. Then I'd have a minus 2y from the outside and a minus 2y from the inside, so that's a minus 4y. And then minus 2 times minus 2 is a plus 4. And now I can bring all of my terms on the same side and solve by factoring. So, take your y here, minus it across. How many y's are there now? Okay, 5. So, y squared minus 5y. Then I'm going to minus my 10 across. What's 4 minus 10? 6 equals 0. Remember, you can only solve when you have it equal to 0. Then what will multiply to negative 6 and add to negative 5? 2 and 3 add to 5, though. They have to minus to 5. So what about 1 times 6? Yeah. So I'll do minus on the 6 plus on the 1. Which means where are the two y values where these graphs intersected? Okay, so the top one is obviously the 6. The bottom one is the negative 1. Okay? Then from there, to do my integral, I would say area equals, let me draw a little line here. Yeah, we're not actually going to work this one out. We're just going to set it out. So it'll be from negative 1 to 6. Those are my y values. And then which function, the line or the curve, will come first? The line. Because who's on the right side? Yes, remember that when it's dx, you do top minus bottom. But when it's dy, you just turn your head sideways. Who's on the top? Okay, or if you know your left and right, who's on the right? Okay, so we're going to do y plus 10 minus y minus 2 squared dy. Now, quick question. Okay, as that's written right now, y plus 10 does not need u sub. Y minus 2 squared does need u sub. Could I, though, avoid it by expanding this and combining like terms? Yes. Okay, you could. Probably they wouldn't make you do that on the AP test, but if they did, it wouldn't be impossible. Okay? So you'd either separate and do u sub or just keep it all expanded, combine like terms. Do you want to see what that would look like or no? Good? Okay, let me just set it up so you can see it. Don't write it down if you don't want to. Okay, but look, you'd have y plus 10 minus, and then when I expand this, remember how it was a y squared? And then a plus 4y, and then a minus 4. And then I would take this y and that y. I'd have negative y squared plus 5y plus 6. And that's what you'd be taking the antiderivative of. Now, do we understand why all of my signs here are the opposite as what they are here because of the minus? Does that make sense? Okay, and then blah, blah, blah. I'm just going to put etc.
Should we put integral is set up from right to left?
Yes. So let's put that up here at the top. Let's fill in. If you're doing area with respect to y, your equations should be in x equals y stuff form. And instead of your functions passing the vertical line test, they just have to pass the horizontal line test, which means that when I draw a graph, a horizontal line should only touch it twice. So think about like a sideways parabola. That can't pass a vertical, but if I drew the line sideways, it would pass. Okay, your integration boundaries aren't x values, they're what?
Range.
Okay, they're a range because they're y values. And then your integral is set up right side minus left side. Okay? HLT is horizontal line test. It just means when you draw a line, it can only touch the graph once. Okay? So go ahead and turn the page.
Swivel.
I was wondering if I spelled it. Is that how you do etc.?
ETC.
I was looking at it, I was like, maybe that's right.
ETC. Not ECT.
It's fine, okay, guys? Look, I'm not so good at that, okay? All right, turn the page. Okay, so the only difference from yesterday to today is that now you are going to have graphs that perhaps intersect, okay? So take a look at number 3. Now, we're going to just for right now practice setting them up, and then I'll bring you a calculator in a second. But look at number 3. How many areas are enclosed by these two graphs? 2. You see you have your little pocket here, and then you have a big pocket here. Yeah? So I'm going to call that a swivel. That's not like a real name. That's just what I'm going to call it. Okay, because they cross who's on top. So here's what you would do. You would do area equals, and then you would just treat the pockets separately. So for pocket number 1, okay, I'll do this one in purple. Okay, what are my boundaries where they crossed? They're whole numbers. So that's negative 2, right here. And then where does this one cross at? Negative 1. So I'd say from x equals negative 2 to x equals negative 1. And then who is on top for that pocket? Is it f of x, the cubic, or g of x, which is the straight line? So I do f of x, the cubic, minus g of x, plus. And then I treat the second pocket like its own area. So where do they cross over here? 3. So I'd go from negative 1 to 3. And then what's on top for that pocket? G of x minus f of x. Does that make sense? Yeah? Okay. If you have to do this by hand, that sucks. But if you have a calculator, there's a shortcut. Okay, what tool do you have in a calculator that will take whatever order you're subtracting something and make it not matter? Okay, think about like what's 7 minus 3? What's 3 minus 7? What's the only difference? If I put absolute value bars, it'll turn it always positive. So what you can do is do f of x minus g of x, but then put them in bars, then the order doesn't matter. Now, here's why that's better. If the order doesn't matter, I don't have to break up into 2 pieces. What's the first boundary? Here. Negative 2, right? Because we just want the x's all the way through until x equals 3. Okay, but here's the bad news. You can only do that if you have a calculator. If you're working the integral by hand, you have to do it this way. Okay, but if you have a calculator, you can do it like that. Now, to pull up that shortcut, write it down. Okay, I would do math 9 to pull up the thing, negative 2 to 3. And then to get the absolute value, you're going to hit alpha window. And then do you see right there, ABS? Okay, so I'm going to put absolute value is alpha window. Okay, and that is how you would pull that up. Okay? All right, come down to number 4. How are we going to have to set up the next integral? Will we do it dx or dy? This has to be dy because does this graph pass the vertical line test? No. That means that dx is not an option. Okay, if it can't pass the vertical line test, you can't do dx on it. So first thing I'm going to do is find the 2 intersections. How low is this intersection? Give me a y value, negative 2. Okay, then I'm going to shade all this area in here until what y value? Okay, positive 1. And then which function is going to be on the right side when I set up my integral? It'd be this one. What equation is that? Okay, it'd be the... I'm going to do this, parabola minus line. And then we'd go from negative 2 until 1. Now, let's talk about the parabola. Here's why I don't want to use the equation like that. Remember that your equation has to be solved, but it has to be solved for which letter?
Y.
I want y in it, so I want it solved for x. So that means I can't use that one like that. I can't use that one like that. I'm going to have to fix both of them. So let's do that now. Let's do the line first. If y equals x minus 1, then just add the 1 across. What is that equation as a line for x? Add the 1 across, it'd be y plus 1. So this line here is x equals y plus 1. Now let's do the curve. When they gave it to me, they said y squared equals 3 minus x. I can't use it like that. So I'm going to minus the 3 across. So now I have negative x equals y squared minus 3. Are we good so far? And then I'm going to change all the signs to where x equals, yes, negative y squared and then a plus 3. And that would be for this line right here. Now, I want you to think about for a second, does that make sense if I'm looking at this graph? Okay? Yeah, the negative means it opens to the left, and then the plus 3 shifted it over to 3 on the x-axis. So that makes sense. Then when I subtract my graphs, I would do the parabola minus the line, so it would be negative y squared plus 3 minus y plus 1 dy. Make sense? Okay, now here's the problem. They didn't tell me to find the area enclosed by the graphs. They said on the interval from negative 2 to 2. So am I allowed to stop shading at 1? No, I have to keep shading all the way until 2, which gives me now, instead of only 1 pocket, now I have 2 pockets. So for the second pocket, plus, what are my y values from here to here? This is 1 till 2. And then for that top little pocket here, who's on the right? Turn your head sideways. Who's on top? For this one. X equals y plus 1 minus x equals negative y squared plus 3. Okay? Does that make sense or no? Okay, and then again, the easiest thing to do is, maybe don't turn your whole head sideways, just turn the paper sideways. Okay, who's on top here? The quadratic. Who's on top here? The line. Okay? All right, so you ready to do some on your own? No. Yes. Oh, you need it so? Okay, if you need a calculator, I'll bring you one. Okay, turn to the next example, type the equations in, find where they cross. Because this parabola, since it opens to the side, that means you have to work the integral out dy. Because, do you need one? Because what's this height here?
Oh, okay.
And then that height is 2.
Okay, so we're just doing that area.
Yes. You're doing both areas and then adding them up.
Oh, okay.
Make sense?
Why is that
Yeah.
there?
Need one?
Why is that there?
Yeah. You need one? Okay, type them in. On the next graph, the intersections are not whole numbers. Jennifer, you need one? Okay, so type them in and then find where they cross. Okay, those graphs were nice, easy whole numbers just so we could look at them. Do you remember how to do that? Second calc and then number 5 is intersection. And then remember, push enter twice and then move your cursor next to the one that you want. So we want 1/2 e to the x. It's on the ln button. Just hit second.
What happened to my computer?
What'd you do wrong?
I don't know.
Just calm. Okay, so now that you've done it, you've frozen it, you have to at least let it finish running. Now the only way to not do that is just to turn it off. And sometimes that'll work. And now turn it back on, and then you can change. Or you want to do like regular, do Zoom 6. And it'll be like
How much
How
time
do
do
I
you press
reset my
enter?
windows?
Okay, so watch, you're gonna hit second trace, and then you're gonna go down to intersect. You'll push enter when it says first curve, second curve, and then when it says guess, that's when you'll like move your little guy over towards the intersection that you want. You don't have to get it exact, just get closer to the one that you want, and then push enter, and it should say intersection and then the X value.
When it says invalid dimensions, what do I change?
You did that.
So the first one should be 8505.
Callie.
I'm gonna have to just reset it. No clue what's happening.
Yeah, the first time it said Windows and then I changed Windows to every time.
So,
Oh, I didn't know you changed your window. That could be why.
No, I-
3x,
one
right?
of
It
the
was
people that
on the, when I went to Windows, when I was here, the only thing that was different was it said 500.
You gotta see that
So
one.
that's what it is.
Oh.
Please join here.
Thank you.
Yeah, well, one of them I only messed. 8 minutes ago, she emailed it back.
Well, that's fine. Your graph is fine. Now, if you want to zoom in like mine is, hit zoom, go down to in, and then just push enter. And it'll zoom you in to look at the graph closer. But that's why mine is zoomed in, is because I did that.
Top one is subtracted by the bottom, right?
Yes. Okay? So my first one here was 0.8505. Now, real quick, I know we haven't really talked about this, but why am I doing this one dx? Because both of my functions are functions, right? If one of them was a sideways parabola, I would have to do it dy. But my parabola is regular, e to the x is regular, everything's good to go. Okay, have we found this negative one?
0.6484.
Yeah, that sounds right. Okay, so then for part A, it says, find the area of the region enclosed by the graph. That's this little pocket. So on my paper, before I type it in, I'm going to do area equals the integral, negative 0.6404 to 0.8505 of top minus bottom. Which function is on top for this pocket? What function is this?
No, 1/2 you did.
Yes, this is 1/2 e to the x plus 1. Okay, so when I subtract it, I need to make sure that I put f of x first, g of x second.
I thought the one on top was the one higher.
Yeah, but higher on your shady region. So I'm only looking right here. Who's higher?
Oh.
E to the x. Does that make sense? Now, you're right that the rest of the graph, who's higher?
Okay.
X squared. But on this little chunk of the graph I'm looking at, e's on top.
Okay.
Okay? All right, now let's practice typing that in. Make sure you know how to do that. Second quit. Regular screen. How do we pull up the integral? Math 9. Very good. Math. Scroll all the way down to 9. Or just push the number. Negative 0.6404.
8.84.
64. Was it an 8.4?
Yes.
Oh, I wrote it wrong. Thanks.
This.
6484.